up till now, we've done basically most of the derivatives. We know how to take the derivative of x to a power. We know how to take the derivative of trig functions. So now we're going to learn how to take the derivatives of exponentials and logarithms. Yes, let's go to writing mode. Luckily, for exponentials, it actually is really straightforward and nice. The derivative of e to the x is literally just e to the x. It is its own derivative. It's more complicated, however, when you need to take the derivative of e and then like you have something more complicated than x in the power. Like let's say you have e to the tan x. Okay, for this you're going to need to use the chain rule. So what I recommend you do is you do something like this, where you say, hey, this is the derivative with respect to x of e to the u. And your u will be the tangent of x. Now remember, the way that the chain rule works is that you're going to have the derivative of f with respect to u times the derivative of u with respect to x. So in this case, your f of u is e to the u. So if your f of u is e to the u, what is the derivative with respect to u? Well, we just learned that the derivative of e to the x is e to the x. So the derivative of f with respect to u is just e to the u. Now you have to multiply that by the derivative of u with respect to x. If your u is tangent, what's the derivative of u? What's the derivative of tangent? Yeah, secant squared x. So let's move all this over a little bit because it's like in the way. Looks weird right there. There we go. That looks better. So you have to multiply by secant squared x. Now you have to make the replacement back. So what's e to the u? E to the u is e to the tangent x times secant squared x. So the way this works is if you're taking the derivative like e to the tangent, you're just going to get e to the tangent again. And then you multiply by the derivative of tangent, which is your secant squared. Okay, so we'll do another one. Let's say that you wanted to take the derivative of e to the x squared. So what I would do is I would rewrite this as the derivative with respect to x of e to the u. And in this case, my u is x squared. So what's my du dx going to be? 2x. So remember, the chain rule says you're going to do the derivative of f with respect to u times the derivative of u with respect to x. My f of u is e to the u. So what is my df du? Again, it's just e to the u. So I get e to the u times the du dx is 2. Okay, and then I need to replace what the u is. My e to the u is e to the x squared times 2x, which we would usually write as 2x e to the x squared. Notice, it's like what I said earlier. The derivative of e to the x squared has an e to the x squared, and then you're going to multiply by the derivative of x squared. Okay. So taking the derivatives of exponentials with base e is rather simple. Now we're going to talk about what if you want to take the derivative of a logarithm, base e. So the derivative of natural log x is, and this is pretty simple, 1 over x. So that ends up working really nicely. Like the derivatives and exponentials and logarithms are quite straightforward. It gets more complicated, like just like with the exponential. If you have something more complicated than x in there, like what if you want to take the derivative of the natural log of, I don't know, what should we put in there? Let's say you want to take the derivative of the natural log of x squared times sine x. So it works just like what we did before. You set your u equal to what's inside there, x squared times sine x. And the chain rule tells you you're going to take the derivative of f with respect to u times du dx. Okay, our f of u is natural log u. And we just learned that if you want to take the derivative of natural log of u with respect to u, that's just going to be 1 over u. So df du is just 1 over u. Now you have to multiply that by du dx. So I need the derivative of u with respect to x. Okay, which means I'm taking the derivative with respect to x of x squared sine x. Which derivative rule am I going to have to use to calculate that? So I'm taking the derivative of x squared times sine x. Which derivative? Yeah, the product rule. So you got to do the derivative with respect to x of x squared. You're going to multiply that by sine x. You're going to add to it x squared times the derivative of sine, which is going to be 2x sine x plus x squared times cosine x, right? Because the derivative of sine is cosine. So that just ends up over here. So we get 2x sine x plus x squared cosine x, and we should put parentheses around it. Okay, now you can multiply that across. The 2x sine x plus x squared cosine x will end up in the denominator. And you have to divide that by u, and what was our u equal to? X squared sine x. Boom. That is your derivative of the natural log of x squared times sine x. I guess you could simplify this a little. You would get 2x sine x all over x squared sine x. You don't have to, but let's just see if it simplifies anything nice. And then you would get x squared cosine x over x squared sine x. If you cancel, you're going to get the signs over here will cancel. This x and that x squared will cancel, and you're going to get 2 over x plus, now the x squareds will cancel, and the cosine over sine becomes cotangent. Both of them would be acceptable answers. Or I guess really what you should probably do for this one up here, you could cancel out one of the x's, or you can rewrite it as this. Either would be correct is what I'm saying. What's annoying about these is you might get several different ways to write your answer.